Hello friends, I'm Mohnish and today we are going to look at a new data visualization project which is on cardiovascular disease, like mainly blood pressure and cholesterol levels. So let's get started quickly and let's run our Jupyter notebook. I think I typed a command earlier. Yes. Okay, so there is spelling error. So let's go and let's give it the time. Meanwhile, we'll just look at a chart here. So here we are having the blood pressure category and systolic like mercury levels, like it's the upper number of the blood pressure, and diastolic mercury levels in millimeters is the lower number. Like for a normal person it should be less than 120 and less than 180, and for an elevated, like prone to some disease, it can be 120 to 129 and less than 180, like less than 80. And high blood pressure, like this is for hypertension stage 1. It's like it crosses from 130 to 139 and all that. So you can see the chart and you can guess how it is. And let's go to our file. It is P193 and this is our folder. Meanwhile, before we get started, we'll just look at its data file, like the data set which we are using. So it's another data set from the internet, and let's have a look at this CSV file. Okay, so this looks great and the kernel is still starting. So here we have an ID which is of no use for us, and here we have the age of the person, the gender. So 1 is male and 2 is female here, and height is height of the person, weight, and this systolic means lower one, like higher value, and diastolic is the lower value, and what cholesterol he has. I think these are the levels. Glucose, is he a smoker or not. If he doesn't smoke, it's 0. If he smokes, it's 1. Then all that other things are there here. So we are going to use this data set and we are going to take out some plots and line graphs out of it, and we are going to see how it is done. So let's don't save for now and let's start running our code. Okay, so I'll just shift enter and okay, plot a line graph to get the average cholesterol found in various HP groups, and plot a line graph to find the correlation between systolic and diastolic blood pressure found in various age groups. So this is our two tasks like which we have got. So we have to plot a line graph for the average cholesterol level found in various age groups. So let's start doing that first. And task 1 for us will be importing all libraries and reading the cardiovascular.csv, which is our CSV file. You see cardiovascular.csv. Now let's go and let the pandas and matplotlib get imported. So pandas, it's for reading the data frames and for performing operations on data tables, and matplotlib is for plotting the line graphs, and we are reading the CSV file using this syntax, and we are getting the data types, and D types means data types. So ID is int, age is float, okay, so we don't need that, like if it's float and integer. For us everything is integer, so it's easier for us to get to the visualization. So now let's see the data frame once. So this is the same data frame, like just wanted the columns just for reference. So I'll do df.head 1, so I can just see the is okay. So this is quite better. So average cholesterol found in various age groups. So we are going to group by age here. So we are going to df like data frame. This is our data frame here which we stored here. So I'll just even comment this and run this again so I can scroll easily. So group by age. So we are doing df.group by, and we are grouping it by age and by cholesterol, and we are finding the mean. So you mean here we are finding the average, like of all ages, like for we have 20 years, they have 5 people. So for all the 5 people, we are checking the cholesterol and finding the average of them, and we are setting it in the cholesterol value for that age group. So if we think cholesterol for 20 age group is 1 2 3 4 5, so not actually, just for example. So it will be around 15. So we are going to 15 by 5, so it will be taken as 3 as the mean. So you that's how it works. And reset index is for getting the IDs like 1 2 3 4 5 6 7 8 instead of the IDs in this. So let's group it by age, and you see we get an age starting from 29, 30, 39 and all that. So because you see it's a float data type, you get the decimal points here. So but if we just do df dot age, df dot as type, df, here it will be like this, df age dot as type int, and let's do this then. Okay, so I need to store it in df also, df age, and let's try this. So you will see we get all integer values here. So you see, so what I did here was typecasting. So I just typecasted the data types here, and we are getting integers, so that doesn't matter for us a lot because decimal points to age are not so much valuable here. And we are getting to end of the task, which is plotting the correlation between the cholesterol and the age group. So here we are going to get the labels, which are the age here. So labels are like the things which are represented on the x-axis here, and values are the y-axis things. So on x-axis we are going to display the ages, and on y-axis we are going to display the cholesterol levels. And we are creating subplots to get a figure size and all that, and we are plotting it, and we are seeing we are setting the line width and all that, and we are showing the legend. So legend, I'll be showing you what is that, and we are setting the x label, y label and title of it. And so you see what happens here. So it's running, and you see the title gives us this heading, the legend gives us this blue line is for average cholesterol, this legend, plt.legend, and show is showing us the thing. And you see here we are getting values for cholesterol on y things, y axis 1.1 and all that, 1.6. You see the values are fluctuating from 1.1 to 1.62, so that's absolutely fine. And the age groups are from 30 to 65. And you see here we get cholesterol and age because we use plt.x label as age, plt.y label as cholesterol. And we are setting the font size of this to 20, and we also set the line width of the pipe, like line graph, to 3. And if we change it to 10, you see we get thicker lines here. But for us, thicker lines means it's not convenient because sometimes the results gets inaccurate while studying the data. So this is quite thin also, so I think 3 was the best, I think. So it's kind of like seeable and good to see. And let's conclude something from here. So we can see the above graph shows how cholesterol starts increasing after the age of 30. So you see age 30, it's constant, it's 1, but after age 30, you see as the age increases, the slope is straight, like directly increasing here, and it starts fluctuating from this data set. I'm not saying like anywhere or anything. According to this data set, it's fluctuating in their averages. So now let's go to the correlation between systolic and diastolic blood pressure. So we are going to get a systolic and diastolic blood pressures. So you see this is systolic blood pressure and this is diastolic blood pressure, and I'm going to give you an overview what we are going to do. So what we are going to do is we are going to compare these systolic and diastolic values according to age, and we are going to get a line graph out of it. So we are going to group it by age, systolic. So this is our name variable which stores it, and then we are grouping it by age, and by systolic blood pressure, and we are maxing the value. So you would say mean would work, but mean is not giving the results we want here. So we'll be trying once with max and once with mean as well. So we are going to reset the index, and here I'll remove the d types, it's not needed, and let's see. So you see we are getting the age and systolic blood pressure here. So see the values, it's so high for some people. We have just seen in this picture higher than 120, higher than 180 is dangerous, but here people are having in thousands, 10,000s. So that's kind of very high. I don't think the ADMA, but these might be some errors in ES data. So I think we might remove them if we had some more time, but for now we'll just let it to be here. And we are going to group the diastolic. This one was for systolic and this is for diastolic. So we are going to group it by age and diastolic blood pressure, and we are going to max it here again and reset index, and let's print it. It's the same thing we did, but instead of systolic we use the diastolic blood pressure here from the data frame. You see that this is systolic and this is diastolic, and then let's make this variable here. So you see diastolic, so even diastolics are also hitting to 10,000s. So that's very strange. So that's not a matter to discuss now. Now let's get to our line graph here. So we are setting this group by age systolic label and group by age systolic value. Like we are going to have to find a correlation between them. We are going to plot these both data sets into the same line graph, and that's the catch we are going to do here. That's something new we are going to do in this video, and we are going to group it by age systolic label. We are setting the value of age here. Like this is a new variable which is storing the label here. Before we had seen label and value, we had just given label and value, but here we are using two data things like data sets, and we are plotting both data sets data onto the same line graph. So we are specifying the variable name as it is, so it will be helpful for the readers. And you see the group by age systolic label is group by age systolic age. You see the age, so this is a group by age systolic. From that it will take this age parameter and store it as a list here, and same it will do it for the blood pressure here. And we are getting the PLT1. We are making subplots here. By subplots we'll be putting that in here, putting it into our line graph, and we are going to plot this, you see, and we are setting its label to average systolic blood pressure and line with 3. So this label will be shown if we use plt.legend, and it will show which color it uses. Mostly firstly there's a sequence. So what I observed, firstly the Python uses blue, then orange, then some dark blue shades, and then green shades. So I've seen that. So it follows a distinctive rule, and we are doing the same thing for group by diastolic. So instead of systolic we are taking from diastolic age, and here again we are taking from diastolic, we are taking the diastolic blood pressure, and we are plotting it here. So you might think, how are you plotting two graphs? So we are using something which is subplots here. So we have to remember that we are using subplots, so it helps us to plot two graphs here. And then we are doing the X label is age, Y label is blood pressure. You see age and blood pressure is the same, but we know we have two different blood pressures. So blue line is probably going to show the systolic, and orange line will show the diastolic. So that's thing, and our title is correlation between that. We all know these things, and we are going to show the legend. So these labels are shown. So now let's see the execution, which is our main thing. So you see average systolic blood pressure and average systolic average diastolic blood pressure is shown. So you see, let's concentrate on the diastolic first. So diastolic is the low value. So you see it hikes from 30 to 40, and it keeps on fluctuating the diastolic value. and it meets at 65 again, like perfectly. It syncs with it. But you see the average systolic value. It's it's peaking up till 16,000s, where it should be around less than 120 for a normal person. So I think there might be some errors in this data set, personally. So you see, blood pressure is hiking from 40 to 60 age. You see the line graph is almost hitting the, it's skyrocketing here, and that's not so good here. But we can conclude people's cholesterol, like blood pressure, is increasing when they're 40 to 60 years, so they should take care at this time 45. So I concluded that also. So that was my project for today, friends. Thank you for watching this video, and if you are liking this video, smash the like button and subscribe this channel so you don't miss any more videos like this. Stay tuned. Bye bye.